IBESS, Water and Aquatic Food Production Part 5, will focus on the ways in which water supplies for people can be strengthened. The significant ideas are the supplies of freshwater resources are inequitably available and unevenly distributed, which can lead to conflict and concerns over water security. Freshwater resources can be sustainably managed using a variety of different approaches. This movie will evaluate that variety of different approaches. Here is the first of two slides displaying the outline of the movies available in the Water Aquatic Food Production Unit. Use this outline to find the movie you need for review. This movie is focused here. Here is the second slide outlining the movies available in the Water Aquatic Food Production Unit. Use this outline to find the movie you need for review. All the fresh water that was available to humans 10,000 years ago is still here with us today. So why is it that fresh water feels scarce? Why would societies need to strengthen freshwater supplies? Population numbers have increased, putting stress on existing freshwater storages, especially in desert regions. As well, people have polluted most of the existing surface water storages. So here is the IB syllabus statement that drives this movie start to finish. Describe and evaluate water enhancement measures that provide for increasing demand for fresh water. The first water enhancement measure to examine and evaluate is redistribution. Redistribution is when water is moved from locations with more water to locations with less water. A canal is bringing water to this desert region, but access may have more to do with the number of people than with absolute quantities. One limitation of this canal is a loss of water from the canal's surface due to evaporation. China has numerous water redistribution plans from the wet southwest to the dry northeast, from places with higher water availability to regions of lower water availability. In this slide, you can see the yellow and the Yangtze rivers in blue, and the redistribution projects in red. These projects are very expensive. China would like to redistribute water from the Brahmaputra River on the Tibetan Plateau to northern China on the Yellow River, a much drier region. A project like this requires technological expertise in addition to the expense. Canals redistribute water from the Colorado River to arid cities such as Phoenix. The withdrawal of water from the Colorado changes the magnitude of the Colorado River as a storage, and it also changes the biodiversity of the river. Now, can you evaluate the redistribution of water as a strategy to enhance water supplies for people? Stop the movie now or follow along with me. I've stated the strengths and weaknesses in previous slides. I'll let you study this slide on your own, although I'll quickly run through it. Stop the movie to take some notes. The strength of redistribution is that it moves water from places with an excess to places with a deficit of fresh water. Weaknesses: it's expensive, requires specific technology, there is a loss of water due to evaporation from the surface of the canals, and there are changes in the ecology of the river. There's a loss of diversity. Now, let's look at reservoirs as an enhancement measure providing for the increased demand for fresh water. Urbanization and the increased need for agricultural irrigation has increased the demand for water. Dams hold back large volumes of water for irrigation and household use. Dams are expensive to build, and the ecology of the original river is dramatically changed. Dams do provide water for people who need it, but dams also provide electricity, also known as hydropower. When the Three Gorges Dam was built, more than 1 million people were displaced from the river valley. Dams hold water back for household use and agricultural irrigation. Dams also provide hydropower, and the lake behind the dam provides recreational opportunities. Dams are expensive to build, and they have a finite lifetime. Silt fills in behind the dam, and the water held behind the dam is not endless. If the river ceased flowing, the water held in its reservoirs would last 3 to 4 years only. In this graph of flow volume in the Colorado River over time, you can see that the flow rate varied widely before the Hoover Dam was built in the early 1930s. Once the dam was built, flows downstream were quite regular. Dams reduce the probability of flooding downstream and make the water flow quite predictable. Can you evaluate reservoirs of water as a strategy to enhance water supplies for people? Stop the movie now or follow along with me. I've stated the strengths and weaknesses in previous slides. I'll let you study this slide on your own. Stop the movie to take some notes. Now let's look at desalination as an enhancement measure providing for the increased demand for fresh water. Desalination is the process of removing salts from water, salt water, thus producing fresh water from seawater. In these images, you can see the salt piled up after it was removed from the salt water to produce fresh water, drinking water. Desalination requires huge amounts of energy to separate the salt from the water. Desalination plants are expensive and require high technological expertise. Desalination plants must be located near to an ocean. In this diagram, seawater is taken in, it is then screened, filtered, and then reverse osmosis is used to separate the salt from the fresh water, which can be used for drinking. Excess salt is returned to the ocean. Desalination plants are expensive to operate, requiring high quantities of fossil fuel to distill the fresh water from the salt. Can you evaluate the desalination of water as a strategy to enhance water supplies for people? Stop the movie now or follow along with me. I've stated the strengths and weaknesses in the previous slides. I'll let you study this slide on your own. Stop the movie to take some notes. Now, let's look at the artificial recharge of aquifers as an enhancement measure providing for the increased demand for fresh water. The artificial recharge of groundwater aquifers is the process of purposefully moving water to underground storages. This is a process of recharging groundwater storages by injecting water into the storages in the ground. This would help maintain groundwater natural capital. Groundwater recharge is a process where water moves downward from the surface into groundwater. Recharge is the primary method through which water enters an aquifer. The recharge occurs both naturally, infiltration, percolation as part of the water cycle, and through anthropogenic processes known as artificial groundwater recharge, where rainwater and or reclaimed water is injected into the ground. Groundwater recharge often requires technology in the form of tubes, pumps, and tanks, and this could be expensive. Groundwater recharge requires land area, as you can see in this image, for taking up the water and letting it percolate into the aquifer. But the solution is really potentially a low-tech solution, nothing more than land area that allows for the percolation of rainwater into the aquifer. The question is the recharge input equal to the output, the use? Where is the source of the recharge water? Is there enough recharge water to make a difference in groundwater levels? In this image, we can see old recharge tanks in India. Historically, societies conducted groundwater recharge as a low-tech solution to stressed groundwater storages. Artificial recharge is often a small-scale operation, But the question is the input sufficient to equal the output? You can see in the upper image the role of technology in groundwater recharge, and you can see the significant surface areas that are required for artificial groundwater recharge. Can you evaluate the artificial groundwater recharge as a strategy to enhance water supplies for people? Stop the movie now or follow along with me. I've stated the strengths and weaknesses of artificial groundwater recharge in the previous slides. I'll let you study this slide on your own. Stop the movie to take some notes. Now, let's look at rainwater harvesting as an enhancement measure providing for the increased demand for fresh water. Rainwater harvesting is a process by which rainwater is collected and stored after running off of a surface, typically a roof. Rainwater harvesting tends to be a small-scale, low-technology, inexpensive solution to water access. The water collected by rainwater harvesting can supplement the water provided by the government or the local well. One question is the collected water safe to drink? The technology involved in the collection process of rainwater can be more sophisticated than one might imagine. Is the input sufficient to meet the demand? Does the input vary seasonally? Rainwater harvesting is a small-scale, low-technology, inexpensive solution to provide fresh water, to supplement the fresh water that a family might have. Is the input sufficient to meet the demand? And does the input vary seasonally? I've stated the strengths and weaknesses of rainwater harvesting in the previous slides. I'll let you study this slide on your own. Stop the movie to take some notes. Now, let's look at gray water recycling as an enhancement measure providing for the increased demand for fresh water. Gray water is water that is not fully clean, having been already used for washing clothes or dishes or bodies. Take notes here. The water is then stored, it can be filtered, and then the water can be reused in this planter bed. Gray water recycling is the collection and storage of gray water for alternative uses, uses that would otherwise have consumed clean water. Gray water recycling gives water a quote-unquote second use. For example, in this planter. Gray water is water that has already been used for washing clothes or dishes or bodies. Take some notes here. Gray water recycling is a low-tech, inexpensive solution to the collection and storage of gray water. Gray water recycling gives water a second use, for example, in this planter. Gray water recycling can involve some sophisticated technology to ensure the collection of the wastewater from the home, but the technology does not have to be as sophisticated or expensive as this image implies. Moving polluted water through a sophisticated tank that includes microbes and sand or gravel beds can serve to clean the water, and this kind of technology can be used with gray water. These artificial wetlands with plants, microbes, and sands clean gray water. These biological filtering ponds clean polluted water as it passes through the ponds. The ponds have decomposers, bacteria, plants, and sand or gravel beds. Gray water can be passed through beds like this to clean it. Recycled water supplements available supplies. Water, once used, is collected, stored, and used again, but it might not be drinkable. I've stated the strengths and weaknesses of gray water recycling in the previous slides. I'll let you study this slide on your own. stop the movie now to take some notes. Now, let's look at how changing behaviors is a viable solution to enhancing the supply of water. Could societies be more sensible, sensitive, and aware in polluting water less? Could we choose to pollute less? People use the flow of rivers as a means to get rid of waste from their immediate environment. As a result, most surface water storages are not drinkable. Could societies change their behavior as a mechanism to enhance available supplies? How do we treat our surface water, and what does it cost society to clean the water? Could we simply choose to pollute less? What are our behaviors with respect to water use? Do some of us use too much, more than our fair share? Could each of us use less water to enhance available supply? Do societies need to irrigate golf courses? How could we enhance available freshwater supplies? How much water is used when we flush the toilet or wash our clothes? Do some of us use too much water, more than our fair share of water? How could we enhance available freshwater supplies? Irrigation flooding consumes a lot of water. Is there a way to irrigate with less water? Agriculture is the most water-consumptive human activity that there is. Irrigation that uses surface and groundwater dramatically redistributes water. Surface water and groundwater storages are reduced as a result of irrigation, and evaporation of water increases. Could societies use a technology known as drip irrigation? Drip irrigation allows a just right level of water to reach the plants. Drip irrigation reduces the amount of water required for irrigation. It reduces the amount of water that's lost to evaporation from our agricultural fields. Drip irrigation is a technology that allows a just right level of water to reach the plants. Drip irrigation reduces the amount of water required for agricultural irrigation. This is a table that shows water users in the United States, and the water values are given in million cubic meters per day. Irrigation is responsible for the largest withdrawal of water total. And because of evaporation, irrigation is the most consumptive use of water of any human activity. Electric power companies withdraw a lot of water, but they put the water back into the storages, so consumption is not very high. And the domestic use of water is not large in any case. On this table, you can see the water requirements for many human activities. How could we change our behavior to strengthen access to water? And that brings us to the end of IBESS, Water and Aquatic Food Production, Part 5.